James Webb is the most powerful telescope ever built by humanity. Thanks to innovative technology, it can explore the most remote regions of our universe and analyze millions of possible new worlds. Among the many celestial bodies that James Webb will study is the exoplanet Proxima b. James Webb will point its lens at this distant planet to do something unprecedented and in some ways revolutionary. It will search for artificial lights that could reveal the existence of an alien civilization. But why have scientists chosen Proxima b? What makes this planet special? Join us on this wonderful journey into the depths of the universe to discover how and why scientists are searching for artificial lights on Proxima b. Beyond our solar system, there are billions of planets unknown to us. Planets outside our solar system are called exoplanets. Most of them orbit around a star, but not all of them. There are also planets that are not bound to a stellar orbit and float freely in the universe. Although there are many exoplanets in the universe, most of the ones we have discovered are located in a relatively small part of our galaxy. By measuring the sizes of exoplanets, their diameters, and their masses, scientists try to understand the nature of these planets and determine whether they are rocky planets like Earth and Mars, for example, or gas-rich planets like Jupiter and Saturn. Exoplanets are made up of elements similar to those that make up the planets in our solar system, but these elements can be combined in very different ways. For example, we could find planets covered in water, ice, iron, or carbon. The observation of exoplanets is a relatively recent discovery. The first ones were observed in the 1990s, and since then, thousands have been identified. However, identifying a planet outside our solar system is very challenging. It is not possible to observe them with our telescopes, as we do with Mars or Saturn, for example, but there are special methods for detecting them. One of the criteria for detecting an exoplanet is the transit method, which involves measuring the dimming of a star when a planet passes in front of it. Another method is to monitor the spectrum of a star. The telltale sign of a celestial body passing in front of the star is a slight Doppler shift in its light. Space telescopes have found thousands of planets in this way. The slight dimming of a star's light when a planet passes in front of it has provided us with a wealth of information. The tiny variation in the intensity of a star's light not only indicates the presence of a planet, but also allows us to study the composition of the celestial body, define its size and characteristics. Detecting exoplanets is difficult, and understanding their characteristics is equally challenging. However, over the years, many planets have been identified. But today, with the launch of the new James Webb Space Telescope, researchers have a powerful new eye to search for these unknown planets. Not only is it possible to study the ones already discovered in more detail and gather more information. Among these planets under scrutiny is Proxima b, a very intriguing planet that could hide incredible surprises. But why is Proxima b so interesting to scientists? To understand why Proxima b generates so much interest in the scientific community, let's start with its location. The closest star to us is Proxima Centauri, located about 4 light-years away from Earth. This distance is minuscule when compared to the vast distances of the universe. 4 light-years, even though still insurmountable with current technology, give us hope that one day, with the right technology, we might be able to visit this solar system and perhaps even colonize it. Just like our Sun, Proxima Centauri has a set of planets orbiting around it, and one of these planets is Proxima b. The planet was discovered in 2016 by the European Southern Observatory and has since piqued the curiosity of scientists. In addition to Proxima b, there are other planets orbiting Proxima Centauri, including Proxima c and Proxima d, although we are still not very certain about the existence of Proxima d. But why are scientists focused on Proxima b? The interest arises from the fact that the planet orbits right in the middle of the habitable zone of its solar system, where it is possible for water to be in a liquid state and for all the elements potentially conducive to life to develop. Furthermore, the planet appears to have a mass similar to that of Earth, leading scientists to believe that it may not only have liquid water, but could also be a rocky planet similar to Earth. Proxima b orbits its star, Proxima Centauri, which is smaller than our Sun. Unlike Earth, Proxima b has a synchronous rotation with its star, meaning one side is constantly exposed to sunlight while the other remains in darkness. We do not know for certain if Proxima b has an atmosphere, but if it does, simple elements like water, carbon dioxide, and rock would be sufficient to trigger the biochemical processes that could give rise to life. The planet is very close to its star, completing its orbit in just 11 Earth days. The temperature on its surface could range from -90 degrees to 30 degrees Celsius, undoubtedly extreme temperatures, but not enough to hinder the emergence of life forms. Scientists' curiosity about this planet increased thanks to an event that occurred in 2020 when the Parkes Observatory in Australia suddenly recorded a mysterious signal from space. The signal was detected during 30 hours of observations between April and May 2019. In December 2020, the signal displayed a very narrow frequency and bandwidth, which, according to the opinion of many radio astronomers, greatly reduced the possibility that it could have originated from a natural phenomenon. The mysterious signal was nicknamed BLC-1, and its origin appears to be from the Proxima Centauri solar system. Has an advanced civilization sent us a message that we have not yet been able to comprehend? For a long time, the recording of this anomalous signal puzzled scientists worldwide, including Dr. Sophia Sheikh. After extensively analyzing the recording and comparing it with many others, she concluded that the signal did not come from space, but was the result of interference from Earth. According to the researcher, the mystery would then be resolved and would have nothing mysterious about it. Even though the BLC-1 signal may have an earthly origin, scholars are still determined to search for signs of a possible alien civilization on Proxima b. To do so, they have asked themselves, if a civilization had developed on this planet, how could we detect it? As mentioned earlier, Proxima b has synchronous rotation with its star, with one side constantly exposed to stellar rays and the resulting radiation, likely rendering the sun-facing side uninhabitable. Therefore, to search for possible signs of a civilization, we must observe the dark side of the planet. If life could only be possible on the dark side, an advanced civilization that developed in darkness might now need sunlight, its energy. They could possibly use powerful mirrors to redirect its light or employ artificial illumination to light up their cities. But even if that were the case, how can we observe such phenomena on a planet so distant? Until a few years ago, detecting such activities would have been impossible. However, today, thanks to the brand new James Webb telescope, this could become a reality, and a team of researchers led by Harvard astronomer Avi Loeb aims to seize this incredible opportunity. By utilizing the technology and tools capable of analyzing the infrared present on the James Webb, scientists intend to search for the telltale light waves of artificial illumination on the dark side of Proxima b. They have envisioned two possible scenarios. The first is to look for signs of artificial lighting with the same spectrum as LEDs commonly used on Earth. And the second is to use a narrower spectrum that leads to the same proportion of light as total artificial illumination on Earth. From an initial analysis of the telescope's capabilities, the team has realized that this is possible. All that remains is to point James Webb towards Proxima b and wait and see. What do you think? Will James Webb show us signs of civilization's activity on Proxima b? Let us know your opinion in the comments, and to follow our new videos, subscribe to the channel. Until the next video.